Thank you very much. It's an honor to be here, and it's great that the Competence Center is organizing an event like this. I'm happy to be here to present about 5G, current status, expectations, and relationship to sustainability. In fact, that's 3 different topics, so it's a challenge to cover everything in just 30 minutes. And before I start covering the title, maybe it's good first to tell a little bit about Ericsson, because maybe not all of you know Ericsson as a company. So we are a global company present in more than 180 countries. We have around 100,000 employees, revenues around 25 billion euro annually. We also hold 60,000 patents, of which also a lot in 5G, of course. In Europe, we have 35,000 employees, of which 14,000 are in R&D. Across Europe, we have 21 R&D centers. And I'm proud that also in Germany, we have 3 R&D centers, 1,000 employees in R&D of the total of 2,400. We are established in Germany already more than 60 years. So we're talking about 5G, and indeed in the introduction, the moderator referred to 2G, 3G, 4G. So in order to put it into perspective, on average, every decade, we're talking about a new generation of mobile technology. 5G brings, as you know, low latency, higher bit rates, massive IoT. And already now, we are also already researching 6G. 6G will be an evolution of 5G, and also Ericsson Germany is involved in several 6G programs, both academic programs and industrial programs. I'm also proud that Ericsson is considered a leader in 5G. Here are a couple of references. We were ranked as a leader by Frost Radar, by Gartner, already for the 3rd year. And we were also ranked #1 sustainable telco vendor by ABI Research. So sustainability has become more and more important in 5G development. And now there's also this separate ranking on sustainability. Okay, so far this introduction on Ericsson. Now let's look at 5G, the global view. What is the current status? So 5G has grown quite rapidly during the past couple of years. This animation shows the number of 5G measurements taken with speed test, which represents also the use of 5G. So we can see that it is adopted across all continents nowadays. 252 live networks nowadays, of which 152 also provided by Ericsson. We expect by the end of this year 1.5 billion 5G subscriptions globally. So that illustrates that the technology is really picking up very rapidly. But what is there to come? Are we ready yet with 5G? No, I would say 5G is still in its infancy. What is there to come? And I think the 5G standalone will be a very important next step in the development of 5G. This picture is different from the previous picture. This picture shows 5G standalone across the world. Standalone is an important next step. It means that you have a dedicated 5G network, because most of the 5G networks nowadays globally are 5G radio connected to a combined 4G, 5G core. 5G standalone means that you have a separate 5G core which provides new capabilities such as network slicing. And network slicing is a very important feature for an operator in order to offer different types of services, different quality of services. You can offer and guarantee a certain quality of service to one customer and another quality of service to another customer without that they interfere with each other. And we think that 5G standalone should be a very important development for, let's say, the next wave of 5G. And this picture illustrates that in countries like India and China, they are ahead with 5G. If you compare to Europe, ahead with 5G standalone. It's because they skipped actually the first wave of 5G and started with 5G standalone from the beginning. In Europe, you can also see that Germany is ahead of the rest of Europe. So that's the good part of the news. And that's because in Germany, there are already operators who have launched 5G standalone. And also, there's quite a lot of enterprise networks, 5G, with a standalone core network. So what can you do with 5G standalone? I already mentioned the network slicing. So network slicing allows an operator to be much more, to give much more possibilities to offer, for example, fixed wireless access. Fixed wireless access as a replacement of fiber. Network slicing also for premium connectivity. Public safety networks. That's also another good illustration of network slicing. If an ambulance, for example, which has a broadband connection to a hospital, and the ambulance is driving to the hospital, and it passes next to a stadium where lots of people are gathered together using 5G, then you don't want this broadband connection of the ambulance to go down, or to the bitrate to decrease. And that is exactly the added value of network slicing. Industry use cases. The industries, they definitely want low latency. That is important for controlling remote robots in the industry 4.0. Special cases like live broadcast, extended reality, augmented reality. All these kinds of use cases we expect will rapidly grow thanks to 5G standalone. If 5G is applied in so many ways, and if there are 1.5 billion 5G subscribers by the end of this year, you may wonder, how much energy does this consume? Mobile networks, sometimes I meet people who think that mobile networks consume a lot of energy. And what is actually happening there? This picture illustrates, in the past decade, the growth of traffic, a 300 times growth in traffic in one decade. And the energy consumption of mobile networks has just grown only 1.5. So that is, I think, an enormous achievement. There is no direct correlation between the amount of traffic and the energy consumption of a network. It's decoupled. It's different like with a car. Yeah? If you want to drive 2 times faster, you have to push the gas deeper, and the car will consume twice as much, or maybe even more, petrol. But in mobile networks, this is not the case. So it's decoupled. Still, the annual cost of energy in mobile networks is $25 billion US. That's what all mobile operators pay together on the energy bill. This figure, by the way, is from 2 years back, even before the energy prices were going up rapidly. So maybe this is outdated, but it illustrates also that the operators, they really are confronted with energy bills, higher energy bills, and they want the cost of energy to go down. So on companies like us, Ericsson, where We are providing the network equipment. There is a lot of requirements to make the network equipment more energy efficient. In addition, we also want to reduce carbon emissions to be more sustainable. That goes hand in hand. And since last year, Ericsson has announced that we are committed to become net zero by 2040. Net zero carbon emissions by 2040. We use the ITU definition when we speak about net zero. And according to this definition, you need to address the entire value chain. So net zero is something different than carbon neutral. If you say, I want to be carbon neutral, then you only look at your own emissions. And you may decide to plant trees in order to compensate for your own emissions. But net zero goes a little bit further. Net zero, the scope is the whole value chain, including your suppliers and including the products in use after you have sold them. So if you commit as a company to become net zero, it also triggers you, it pushes you to communicate, to engage with your customers and with your suppliers in order to be aligned in the carbon reduction goals. In supply chain, we aim to halve emissions by 2030. Our own activities, we aim to bring them down to zero by 2030. And in portfolio, also we aim to halve emissions by 2030. So in 2040, our goal is to be net zero overall. So in order to understand the impact, you need to know what is our value chain. So what do we do as Ericsson? Our core business is to develop network equipment, so design, production, software development, etc. We produce products like this. And they are being used by our customers. Yeah, Vodafone, Deutsche Telekom, Telefonica, etc. But in order to produce these products, we need components, PC boards, chipsets. We also need these things to be transported. And in addition, if you go all the way down in the supply chain, you need raw materials. You need aluminum die casting, etc. So if we commit to be net zero, we also need to address all these steps in the development, in the life cycle, I should say, of our products. And in the end, of course, products are being recycled. And we are proud that if we take back products, 98% of the weight is being recovered as raw material. So if this is our value chain, how much is the CO2 emission across these various steps in the value chain? That's the next picture. And you can see that our own activities as Ericsson are actually the lowest here, 0.3%. That is our buildings, our car fleet, the energy we use, business travel. And of course we will address that, and we have a target to bring this down to zero by 2030. The supply chain is 9%, but you can see the big bar is the portfolio use, the use of the sold products, the products in the field. This may not be applicable to all operators. For example, in Germany, some operators are already 100% on renewable energy, like Deutsche Telekom, for example, T-Mobile. They are using 100% renewable energy. But this is a global picture, and we as a global company, we need to address net zero across all our activities globally. So portfolio use is a very important area, I would say the most important area, in order to address when we have a goal to be net zero. That means that we need to develop products which are energy efficient. So from that perspective, it's important to bring down cost, but also in order to reach our goal for net zero. So our pathway to net zero is illustrated here. You can see the intermediate targets in 2030, as I already explained. And by 2040, we strive to be in net zero. Maybe not all our emissions can be brought down to zero. That's why, in the end, we also aim to have carbon removals, carbon capture and storage technologies. But that is something we are already investigating, but it's something for the long term. So back to the products in use, energy efficiency. In this picture, you see what 5G can bring to operators. Hardware modernization. In the past, 3G was built next to 2G, and 4G was built on top of the installed base of 2G and 3G. The result is a site like this. If we would build 5G in the same way, adding more hardware to the existing installed base, indeed, the energy bill of the operator will rise. But 5G will also bring hardware modernization. It is possible for an operator to introduce 5G with equipment that also is compatible with 2G, 3G, and 4G. The site on the right side also has massive MIMO covering the midband, which means that the capacity of the site is multiplied by a factor of 10. 5G is also 10 times more efficient than 4G. If you transmit a certain amount of data, let's say 1 gigabyte, with 5G, massive MIMO technology in the 3.5 gigahertz band, you would need 10 times less energy than with 4G. So how is that possible? This is an example of hardware modernization. The product here is a massive MIMO product in the 3.5 band. The product on the right side, a next generation of the same product, the same features, the same capacity, but it is only 14 kilos instead of 25, much less materials. It means that in order to produce this equipment, you would need much lower carbon footprint. 46% reduced carbon reduction, and also 40% less energy consumption during the operation. This is the result of hardware modernization, of increased integration of functionalities in the hardware. Here is another example. For those of you with a technical background, you may understand the abbreviations here, but basically what it means is that in the past, you would need separate hardware units for separate spectrum bands. And nowadays, we have, first step was dual band, and now we have triple band equipment, which means you have one box which covers 3 different spectrum bands. And this one box, like the previous picture, has a much lower carbon footprint for the production, much smaller in size than it used to be, and also lower energy consumption. This is also what we have implemented in practice. Here are a couple of examples. For example, with British Telecom in the UK, we have managed to achieve a 40% energy consumption reduction by installing a new generation of hardware. With T-Mobile in Germany, in the area of Dittenheim, we are experimenting with renewable energy, a combination of wind and solar. And currently the result is that 28% of the annual energy that is required can be generated on the spot by renewable sources. And the example on the right side with operator Rogers in Canada, we managed to reduce an enormous amount of carbon emissions because of software features that put hardware in sleep mode when the traffic is low. This example is from Canada, but we are engaging with operators all over Europe, also in Germany, to implement software features to put hardware in sleep mode when traffic is low. And there are many different features for that. You can put hardware in sleep mode, let's say during the night, during several hours, but also during milliseconds. Milliseconds to switch off a power amplifier without users noticing it. So that is a result of the development that is going on, the innovation in 5G. Then next, digitalization is also fundamental for sustainability. The total footprint of the whole ICT sector, I'm not talking now only about telecom networks or only about mobile networks, but the whole ICT sector has a carbon footprint of 1.5% of the total global emissions, 1.4%. But by applying ICT solutions in other sectors, like for example in logistics, in Industry 4.0, in buildings, in the automotive industry, in agriculture, we can save emissions in other sectors by 15 to 20%. So there is a kind of leveraging effect of digitalization. If you want to know proof points of this statement, I refer to these reports. Exponential Roadmap, that's a consortium where Ericsson is a member, but also, for example, World Nature Fund and several Swedish academia. Here's another report, Connectivity and Climate Change. So what connectivity can mean to slow down climate change. And this is not the only report. There are numerous reports in this area. By the European Commission, for example, we speak about the twin transition, the digital and the green transition. The enablement effect by GSMA. And another report by MIT, together with Ericsson, about how to decarbonize industries with connectivity and 5G. Let me give a few examples. This is a picture of the port of Livorno in Italy, where we have installed 5G already 3 or 4 years back. And with help of sensors connected with 5G, the harbor logistics were developed in such a way that the loading and offloading of containers was much more efficient. And this has resulted in enormous cost reduction, 20% cost reduction, and maybe even more important, 8.2% lower carbon emissions. If you want to know more about this case, then you can find it on the Ericsson.com website. Just search for Livorno, and you can find this. Another case, recent case in Sweden and Finland. We were working together with a company called Kiona, who has AI-enabled software in order to optimize energy use in buildings. And we're talking about district heating here in Sweden and Finland, 356 buildings. So this is not a pilot, this is operational. It covers 1.5 million square meters, many households. And this has resulted in a 7% reduction of energy usage. And you need to understand that buildings, they count for 36% of greenhouse gas emissions in the EU, so it's a very relevant case. In total, 17.3 gigawatt hours of energy was saved, representing 1 kilotons. A couple of examples from Germany. Already in a very early stage, we collaborated with Fraunhofer in the production of blisks. These are components of engines, and they need to be produced very precisely, and therefore wireless sensors were needed, connected with 5G, and through this innovation, we were able to save a lot of costs and save a lot of energy. For one factory, the savings would be around 27 million euro. But if you would extrapolate that for the whole, let's say, blisk production globally, it would result in a 360 million euro savings. Another example is Ericsson collaborating with Porsche, implementing 5G for Industry 4.0 applications. And the picture on the right is a collaboration with the German company Mira, teleoperated driving. This is, I think, also a very good illustration of why 5G is required in order to control a remote car on the public streets. Mira has a license to drive in Düsseldorf. You would need low latency, high bandwidth for the cameras, etc. So here we demonstrate the application of a future way of transportation. Right, I come to the end of this speech. My expectations to summarize. I think 5G hardware innovation will continue. Energy efficiency is a very important parameter for the development of our products. Sleep mode features, which are AI enabled, will continue to help operators to bring down energy consumption and improve energy efficiency. I think the mobile sector will continue also to be a leader in the net zero pathway. There is a huge commitment not only from providers like us, but also operators to commit to net zero by 2040. The GSMA has published a report which explains that 43% of mobile operators globally have committed to net zero. And I also think that digitalization, connectivity, and 5G in particular will contribute to a low-carbon society. And Nordrhein-Westfalen, I think, will continue to be a front-runner in 5G applications, especially for industries. Hereby, I want to end my part of the presentation. I don't know if we have time for questions. Thank you.
It's not part of our plan today, our schedule, but if you're here in Essen for a...
Yes, I will be here.
Yeah, here?
Yes.
Okay. So, Sie können natürlich weiterhin das Gespräch suchen mit Herrn Bankers. Hier erstmal dieser Impuls von 30 Minuten. Herzlichen Dank für das. Perfekt in der Zeit zu dem. Dankeschön.